All right, welcome back. This is Computer Science 164. This is Lecture 1, and today we actually dive into all things related to design, some of the technical things we'll be doing throughout this semester, and giving you a sense of where you'll be headed for your very first project. So recall from last week that we'll have weekly labs. We're still finalizing times in place with the registrar folks, but for now we will have labs, let's say Tuesday, Wednesday, Thursday, 6 to 8 p.m. This is in Pierce 301. It's the top floor of Pierce, which is at the engineering school. It's a really nice new space that fits about 40, 50 people, all at open workspaces, and you bring your laptop, you bring your power cord, and these will be hands-on opportunities to not only experiment with some of the ideas of the week, but also for one-on-one design guidance from multiple teaching fellows that will be staffing each of these. They are optional, and the lab activities that you do during these things will be placed online so that if you and or your partner can't make some week or any week, realize that you can still follow along at your leisure on your own. So ideas. So the first project and the third project are going to be assigned by us, the staff. But the second and fourth projects, recall, are up to you to choose, whereby you and your partner will decide over the next few weeks exactly what mobile web app you would like to make, what mobile iOS app you would like to make, propose it to us by the dates on the syllabus. We'll give you then some feedback, and then you'll be off for that 3 or 4 week period implementing it. If you would like, though, to post ideas for classmates, or if you've just got so many ideas that you want at least someone to go do it, do feel free to post to this website here. We made a new mobile category, and just over the weekend we actually solicited ideas from staff and faculty all across campus, so you might see a lot of folks from outside of the class posting ideas. What we've told departments is that for those choice projects, you are quite welcome to collaborate with one or more administrators or tech people on campus. For instance, if you work for some department or even some student group that has an actual problem that they would like solved in a mobile context, that's fine if you're actually delivering a product to a group or department that would actually use it, so long as the work is primarily that of you and your partner. It's certainly fine, though, for the staff or even student group leaders to provide you with the so-called design or business requirements of the app if your project might actually then solve something useful on campus. So realize that is encouraged and allowed. All right, so a little warm-up. What we'll do today is look at some things very specific to mobile, but then we'll take a step back and talk more generally about how you can implement well-designed web-based applications, and along the way we'll introduce some terminology, some jargon, and also some of the technologies you'll be using over the semester. So one sort of softball question at first, if only to get things flowing. So there's this dichotomy right now in the world of web apps versus native apps. And someone want to just toss out a layman's definition of these two? What's the distinction? Yeah. Perfect. So a web app is something implemented in HTML, JavaScript, CSS typically, and it's meant to run inside of a web browser, whether it's on an iPhone or Android or BlackBerry or Windows mobile phone. It's meant to execute within the confines of a browser. So to use that app, you have to obviously pull up a URL or follow some link to get to it. And a native app, by contrast, is something you would actually download from Apple Store, from an Android store, from Amazon, or whatever the delivery mechanism is for your particular operating system. You can download compiled apps, and those compiled apps are typically written in languages like Java, or in the case of iOS, Objective-C. And you have to, like you did, say, in Cs50, compile the source code you write, actually then upload it to someone else's server, click a link in some app store, and voila, now you have compiled code. So who cares? Why the distinction? And right now, and probably at least for the next couple of years, this is kind of the first design decision you have to make if you're trying to make something for mobile devices. What design decisions or requirements might push you toward one or the other? Just based on your own consumer understanding of these two things. Yeah?
It's easier to use a native app on your phone. Just push a button.
OK. So it's a little easier to use a native app on your phone, right? You push a button, and it's there. You don't have to open Safari or whatever the browser is. You don't have to type in a URL. You don't have to find a link. You just push the button, and it's there. So that's compelling? Yeah?
It's a little more involved to update a native app, because you have to sort of submit it to maybe a store and then have the consumer click on it, whereas a web app, you can just keep updating.
Perfect. So there's a downside too. Native apps come with these hurdles, particularly in Apple's case, which is a little vigilant, or excessively so, when it comes to approving or disapproving apps for the store. So that's to roll out new updates or new programs altogether, you need someone else's blessing. Thankfully, Apple's gotten better over the past couple years about rolling out updates quickly, but you do need still someone else's involvement. Yeah, I'm back.
A web app has the ability, you can just access it from anywhere. You don't have to download something to a new computer every time you want to use it.
OK, OK, perfect. So web apps, though, by contrast, work anywhere, and in fact, on multiple devices, not just the one that you had in mind that we would be using. Other thoughts? Yeah?
I think there's sort of a sense of legitimacy if you have your own native app, because I think while a lot of companies or whatever want their own native app.
Yeah, I agree. And this one's a little harder to sort of explain why. But definitely right now, I do think there's this mindset where native apps just are cooler. They're sexier. They're more real in that you actually do have to go through some process of downloading it. And the funny thing is, on Android phones and on iPhones, you might not have ever done this, but almost always you can open the browser, visit some mobile website, and then click one of the icons on the bottom is, and then say, add icon to home screen, or whatever the text is. And then you actually have what appears then to be a native application. In fact, on iOS, when you do that and add a bookmark to your home screen and then touch the icon, they'll even remove the Safari address bar. So it actually looks like an actual app, but this just isn't done all that often. Yeah?
In terms of making money, it's much easier to charge for native app download than it is.
So very true. If you want to make money, you kind of have to go through an app store, at least in the iOS case where they require that you go through them. So they take their 30% cut. Yeah?
Being listed on an app store can give you free publicity, especially if you're in the top 25 for your free apps.
Yeah, absolutely. So there's the publicity aspect of it. There's like the top apps categories, right? The World Wide Web is a huge place, but the App Store is at least a little more narrowly defined. So if you sort of hit it right and get something out there that people like, you sort of get these nice mushroom effects. But what about more technologically? Like what's compelling about native over web app? Yeah.
Native apps, they usually have better performance.
OK, so you have better performance. You have access to native hardware, things like hardware acceleration for graphics in particular. In fact, most of the fanciest games you've been playing these days, with some exceptions, have been native because they're really designed to run on the actual hardware. Yeah?
The UI is a lot easier to make it kind of look seamless and integrated with the, especially for iOS, whereas for
Definitely.
web apps, do some kind of clever tricks to make it look more like native.
Perfect. And we'll see this quite soon today, whereby you can mimic the UI of an Android phone, an iPhone, Windows Mobile using CSS and JavaScript and HTML, but it's just not quite as polished. And if you're trying to make something that people really like and really maybe want to pay for, these kinds of things can be compelling. And one other I'll toss out there, too, is that you get access to more features in the hardware. Typically, when using a native application, you can use the accelerometer if applicable, or the gyroscope, or the compass, or any number of other hardware-specific features that increasingly are becoming more exposed to JavaScript in browsers, either natively by the browser or via various frameworks that we'll talk about over the course of the semester. But that, too, is kind of compelling. If you want to use the accelerometer, you kind of have to go with some kind of native app. All right, so that's the stage. Now some of the constraints. So this is just a little screenshot from Apple's documentation. And this kind of goes without saying. The screens are smaller, right? So on the one hand, this is nice in that you have to design less screen real estate. But it's also fairly confining in that you have to interact with the lowest common denominator, which is going to be a user's finger of some sort. And you actually have to confine your user interface to be easy to use. And that's definitely been the theme here. So one of the things we'll talk about over the course of the semester is also what you should be keeping in mind when it comes to designing good software from a user experience perspective. So what does it mean to make a mobile web app? Let's get some definitions out of the way. So here is a mobile web app. If you go to m.harvard.edu in your iOS phone or BlackBerry or whatnot, it kind of looks like a mobile app. Why? Well, it's just because whoever made this application used Photoshop and designed icons that were like 57 pixels by 57 pixels. Someone wrote some CSS that put enough padding or margins around each of those clickable anchor tags so that it looks like it's actually a mobile app, but in fact, a mobile native app. But in reality, all you're doing is using sort of age-old tricks in HTML that you might have been using for years to just make something that fits on a screen. And in fact, you could make a mobile web app just by firing up Chrome or whatever browser you have on your own computer, opening gedit or Notepad or whatever text editor you have, and just start writing HTML coupled with some CSS. And then if you really want to get fancy, you can do things like JavaScript. And even though this here is just a screenshot, recall that on last Monday, I did pull up this iOS simulator. For those of you with Macs, realize that as part of the first staff project, you'll be able to download this for free, assuming you have a Mac that's running Lion. But if you don't yet have a Mac or won't be having a Mac during the semester, realize that it won't be until Monday, March 19th, I think we say on the course's website, that you'll actually need a Mac. The first half of the course can be done on most any platform. So let's go pull up Safari here. Let's go and pull up, let's see, a new window here, new page. And here is all caps, m.harvard.edu. Let's see what happens, and voila. So there it is. So in fact, this is actually cached. There was a nice little design feature of harvard.edu whereby if you actually go, actually maybe it wasn't m.harvard.edu. Let me try this once more and see if I can have a nice pedagogical point. Harvard.edu. There it is. Stand by. Not the way to implement a mobile website. OK. So what happened there? So it was appearing to load the main Harvard website, www.harvard.edu. And then it apparently decided, wait a minute, let me not download all of these tens of kilobytes. And let me redirect the user to m.harvard.edu, which is what I accidentally manually typed in the first place. So this is not all that uncommon as to this redirection. And we'll come and look at, underneath the hood, how you can actually do even the simplest of things there. And I dare say there's so many sites out there that don't do this properly. If you read like Google News, and on your phone, just news.google.com, and click through a lot of these links, very often, I at least will be redirected to the mobile version of whatever news site has their article linked there. And then I don't even end up at the article I clicked on because someone decided just to redirect any mobile user by default to m.whatever.com. But realize that for Project Zero, you will have all of the power, and it takes one line of code to actually solve these problems correctly, to detect what the user is using and redirect them to the right place. Well, what else kind of qualifies as a mobile app? So there's Gmail. And Gmail is sort of a genuine, compelling mobile web application, and that makes heavy use of fairly complex JavaScript to really create a nice interactive experience for the user, even if you're not on a very fast connection. If you're on a 3G or Edge connection, even Gmail is pretty good at conveying the illusion that things are pretty zippy. So this is the website, gmail.com, in a phone. This is not the downloadable app that now exists. And so we'll talk over the course of the semester in the context of JavaScript how you can leverage techniques like AJAX and asynchronicity to create the experience of seamlessness and interactivity, while in the background, really, you have a lot of caching and a lot of latency happening that's addressing or causing those problems there. All right, so we could play all day with websites on the mobile web, but we'll just use those to set things up. So how do you make one? All right, so this is sort of HTML 101. There it is. This is HTML5. This is what everyone's talking about these days. Looks pretty similar to HTML4 and prior, but there are some fancier features, just a couple of which we'll scratch over the next couple of weeks. But over the course of the semester, will you be encouraged to delve into some of the fancier features, among them geolocation, figuring out where a user is, local storage, so that you can store actual kilobytes and not just a few bytes of information like you used to be able to only in cookies, and a whole range of other features as well. So let's do a really quick demo here. I'm going to go ahead and let's say open up something called the Cs50 Appliance. So just as those of you who are in CS51 this semester might be using, and we used this past fall in CS50, the Cs50 Appliance is a virtual machine, which means it's an operating system, specifically Fedora Linux, that we have pre-installed into a big file that you can download from via the course's website. You can then install using a program called a hypervisor, something called VMware Fusion, VMware Workstation, VMware Player, VirtualBox. A whole bunch of options exist such that when you download the appliance and that hypervisor, tie the two together and double-click an icon, voila, you are now running Linux on your own computer inside of a window. So former CS50 students from this past fall are familiar with this. Former CS50 students will be glad to hear this version's better, among whose features are nice full screen out of the box, such as I just did here, the ability to just move between the operating systems on your computer if you have a Mac, and a whole bunch of other fixes that we've rolled out. So the first project will walk you through the process of downloading this onto your own computer and using it for projects. Among the compelling upsides for us is going to be everyone then is not only using a standard uniform environment, so we know what to expect and can help troubleshoot issues, it's also designed to mimic real-world web servers. So you will actually have inside of the appliance your own web server running, your own database server running, your own installation of PHP or any other tool that you might want to use. So it's meant to be perfectly representative of what you would get if you were actually using a corporate server or paying some third-party host. Good question. Can you run Xcode in the Cs50 Appliance? No, because the Cs50 Appliance by nature is Linux. Xcode requires Mac OS. Some Googling suggests that some industrious folks have in fact solved that problem using VirtualBox or Fusion or other hypervisors by following detailed directions people have posted online over time. OK, so I came very close there. All right, so Let's go ahead and do this. I'm going to go ahead into the following directory here. So for those unfamiliar, just assume I'm at a command line on my own computer or on nice.fas.harvard.edu or cloud.cs50.net. And I've in advance created this directory called vhosts, which stands for virtual hosts. More on that in the first project spec. But inside of this vhost directory, I've got a whole bunch of source code for today. So if I go in there to lecture 1, I now have an HTML directory. And inside of here, I have a few examples, prefabbed examples, all of which are on the course's website. In the future, because Harvard Hall doesn't have the best or any Wi-Fi, we'll try to post this stuff as early as possible over the weekend, and I'll do my best so that if you want, you can download it in advance and actually have it to play with during class. There are PDFs available online as well. So let me just go into a very simple example in the CS164 the HTML5 directory here. And let me go ahead and open up, let's say, HTML5.html. So I'm using gedit here, which is a cheap little text editor with which some of you are familiar. And here we go. Here is a very simple HTML5 web page with some standard Latin text. So let's just go ahead and pull this up. So this is in that HTML5 directory. What I'm going to do is open up Chrome inside of the appliance, though you can configure your Mac or PC to allow you to use your own browser client side. And I'm going to go to http://lecture1 enter. And I don't have permission to access / on this server. So this is just a web server misconfiguration detail. And this probably boils down to what little Linux command to fix this. So some kind of chmod error. So let's just do a quick sanity check. ls-whoops, that's a lot of files. Let's see. So my home directory is world executable. That's good because that's necessary. The vhost directory is world executable and readable as per the R's and X's over there. Let me go into vhosts here. OK, so this one's broken. So this needs to be like 711, if you recall your web development experience. Let's go into lecture 1 now. This seems to be messed up. So in one fell swoop, I'm just going to go ahead and chmod everything a little excessively. A plus RX means give everyone read and, if it supplies, executability permission. And this is just a quick and dirty way of exposing everything for the sake of class. But in a real server, we would lock some of this stuff down. So let me now go back to my browser, and reload, and voila. So to be clear, and this is the mental model you should have throughout the semester, the appliance is, yes, a computer, but it's also a server running software, web server software, database software. So you're using, I'm using at the moment a browser to connect to the appliance inside of the appliance, because it is both client and server, if you will. All right, so let's go into HTML5. Let's go to HTML5, and voila. So there is a very nice and simple and Latin-based website. But let's actually now pull this up in a mobile context. So for this, I could use my actual phone and pass it around, or we can just pull up a simulator here. So let me go ahead and close harvard.edu. Let me go back to the directory that I prepped in advance here. Let me go into lecture 1, HTML, HTML5, and finally, OK, useless, right? So horrible, horrible, horrible mobile website. So how do we fix this? And how do you start designing with these kinds of contexts in mind? Well, it's actually rendering quite like a desktop browser, right? It is zoomed out to be sort of normal browser dimensions. But normal browser dimensions isn't quite appropriate here. So it turns out with the mobile web, and these are just very easy new features of HTML, some of them specific to Apple in this case, that allow you to actually tell the browser upon downloading this HTML that, you know what, you need to actually behave a little bit differently from usual. So the viewport. The viewport refers to like the rectangular space for which you have all control in terms of the user's experience. And realize that there's going to be a few meta tags and attributes you can use in HTML5 in this mobile context to specify, among other things, things like width. And we can do this very simple. We can fix this very easily, in fact, by a very simple fix here. Let me go back to, let's say, gedit. Let me go ahead and open up devicewidth.html, which is literally copied and pasted from the previous demo, but I added one thing. So how do you make a website mobile friendly, mobile ready, and make it be readable? So you have a little meta tag. Viewport content width equals device width. This is a little messy, dare say, but device width is like a special global HTML-like variable that's just defined by the browser to be 320 pixels, 480 pixels, whatever is applicable to the device. So the end result should be, hopefully, a better experience. So I'm going to go back in my Chrome browser, pull up device width, and there's no material difference. In fact, the markup is otherwise the same except for that meta tag. But if I go back to my Mac or my phone in my pocket and pull up this time the file that is called devicewidth.html, now at least we're getting somewhere. OK, so really just basic building blocks here that we'll very quickly start taking for granted. But it's these little things that make websites sort of optimized for mobile devices. How about a whirlwind tour of some other things that you can do with HTML so we can start taking these features for granted? So you have, and these are all prefixed with Apple's identifier. So you can specify in HTML markup that my mobile website, HTML, CSS, and whatnot, I want to be bookmarkable on a user's desktop in such a way that when they click that icon that says Save to Home Screen, when they then click that icon thereafter, they should not see the address bar. It should actually look and kind of feel like an actual mobile app. How do you do that? You literally copy and paste this into the top of your file. And it will allow a user to bookmark your page more cleanly. You can do simple, sexy little things. If you don't like the gray bar that's usually at the top of the phone that shows what your signal strength is and clock, you can make it black with something like this. And all of the, at the bottom of these slides, you can't quite see it on this projector, there's the URL for the canonical documentation for finding these kinds of things out. So what about a custom icon? You can do that by simply specifying the location of a ping that the phone should use to actually store on the home screen. You can do pre-composed. So this is, again, we won't spend much time on these details, but a normal image is just an image that Apple will then add some sexy glossy look to it. But if you would like to do that yourself in Photoshop, pre-composed means you made it look sexy yourself. It should not do any special rendering of that icon. If your application is not very well designed or is very slow to actually load up because there's a lot of data or JavaScript or the like, well, you can specify that even this mobile web app, just this website, should first display whatever image you have in mind there. So let's actually see these in action and what we can do here. So let me go back to the appliance. Let me go into another file. Let's call it inputs.html, just to see some features that aren't actually mobile specific. They're becoming more trendy in the actual world of just web development, but they're making things more accessible for users. They're making things more user friendly. And in particular, we have new attributes on the input element like this: auto capitalize, autocomplete, autocorrect, many of which are annoying when the user is trying to type something in, placeholder, and then type. So you might recall from 50 or whenever you learned HTML that you have type equals text, type equals checkbox. In HTML5, you have fancy features like type equals email, type equals URL. Who cares? Like, why isn't an email text? Isn't a URL text? Like, what's the value add here? So it's actually not verification. Could be used for that purpose, but yeah, it's for the keyboard. So this is more about user experience. So if I go and pull up in, let's say, the simulator, this file here, inputs.html, not only do the fields look pretty nice, so they have the little gray placeholder text, email, and URL. Notice that if I, with my finger, or in this case the simulator, click on email, I get this keyboard here. Notice the @ sign. If I instead click on the URL, notice that it changes. So these are the little things, frankly, that will speak to the idea of user experience. And again, we'll spend more time fleshing out these details later on. But realize that you have these building blocks from day one. What else can we do? Well, we have a couple of other things here. Let me go back here. Let me pull up this example here. So Tommy could not be with us here today. But if anytime I do live demos with my phone, it costs me money. Let's see. Let me go in here. Let's go into parent directory. If you're wondering how this demo is going to end, it's going to end with a phone call. All right, so just so you can see what this actually looks like and to give me an excuse for having set up this camera here. All right, so there's a real mobile device. And that's the same web page we just looked at in the simulator. I'm going to click that. So this is how you trigger things like this. So if you've ever used Yelp or Google or whatnot and you want to trigger a call, it's just by using a different anchor tag, or rather a prefix of the href.
Oh?
Hi, Tommy. This is Computer Science 164.
Hi.
Where are you now?
Matter.
Oh, so you didn't. So you're not in class.
It's a long story.
All right. Well, we'll talk to you later. Bye-bye.
Bye.
All right. So it works. So SMSs tend to get me in trouble in demos, so we won't do that one. But similarly, can you do SMS? And this all boils down to, much like in normal HTML, you have href equals quote unquote mail to colon, and then you can trigger the opening of an email client. The idea here is the same too. You can simply use tel colon or SMS colon so that the end result is as simple as saying, in the telephone case, something like this. So this is how we're making these things possible in a mobile context. It's as easy as that. And if you actually read through the W3C's recommendation, this is a group that we might make mention of from time to time. There is a standards body in the world known as the World Wide Web Consortium that over time rolls out new standards like HTML5, XHTML, and a whole range of others. And so if you're ever looking for an authoritative definition or answer as to whether something is supported in a language like HTML, the thing to Google is W3C recommendation. And you can actually get the grammar, if you've taken 121 or a similar course, that actually prescribes what these markup languages should look like formally. So that's not to say everyone follows them. Case in point, all of the things prefixed with Apple I mentioned a moment ago are very Apple specific. So everyone keeps going their own direction anyway. All right, what about this feature of m.harvard.edu or harvard.edu, whereby it redirects apparently to this, but like 5 seconds too late? So upon visiting www.something.com, how might the browser or server realize that, wait a minute, this is a mobile device. Let me show the user something else. Yeah, so you can look at the user agent field. So you might recall sniffing HTTP traffic with a tool like Firebug or Chrome or the like, and you can actually see that behind the scenes, not only do you send messages like get index.html or post to something.php, there's also a bunch of HTTP headers that say what browser you're using, what OS you're using, what domain name you just visited, whether your browser supports compression, and a whole bunch of more arcane features. So this is the user agent string that, as of the version of iOS running on my iPhone as of last night, actually sends. Anytime I visit a website on the whole internet, this information is divulged about me. So it's not particularly super secret, but it does tell a little something about you. Now, what's the upside for the server? Well, this is a horrific looking string. For some reason, years ago, the world just decided to come up with crazy looking user agent strings like this. And it changes every time Apple or Google releases a new browser. The version number or something in that string changes. So what does this mean? Well, server side, as Aaron said, you can actually just detect these kinds of things, right? You can use regular expressions, pattern matching more generally, and just figure out that, a user whose browser's just sent me this is apparently running, an iPhone, right? And yet it says Mac OS X, and yet it also mentions Gecko, which is a throwback to earlier browsers. So long story short, parsing these things is kind of a pain, right? You can very simply grep through it or search through it with like preg match in the world of PHP, and you can infer with some probability what it is. And so you could do something simple like this. So in PHP, if the regular expression iPad or iPhone or iPod matches what's in the HTTP user agent string, then what can you do? Well, server side, you can make the decision then, not 5 seconds later, to redirect the user to the mobile version of the website, which maybe is m.example.com or something else, before the user starts seeing the entirety of harvard.edu downloading. So by contrast, what trick was harvard.edu using apparently? Yeah. Yeah, so probably JavaScript, right? Anytime something happens in a browser that did not happen instantly, but rather after the page was downloaded, probably means it was client-side driven, and we can actually see as much. Let me go over to, in my normal browser, harvard.edu. We have a hunch that it is, in fact, JavaScript based. So let me go ahead and view page source. I don't know what the offending file is going to be, but let me just search for .js. So that's Google Analytics, so that's probably not it. That's a comment. That's something. That's Twitter. That's jQuery. This is curious. Check user agent.js. So apparently harvard.edu is loading this JavaScript. Then it's executing check user agent, which is presumably a function inside of this file. So let's see what this is. Check user agent. And indeed, notice what they're doing. It's actually a little crazy. So check user agent is called. And then it's checking some query string. But ... My eyes have gravitated immediately to this jQuery call. Ajax means go make another HTTP request. So the curious thing, and I was delighted to find this as a lecture example, is that you visit www.harvard.edu on your mobile device. It downloads all the files and GIFs and JPEGs and JavaScript files. It then executes this function. It then sends a message back to the server and says, hey, by the way, what browser is this user running? Then it gets a response, apparently, to that success handler function. And it then calls, let's see, redirect mobile, passing in platform as an argument. So let's scroll down here. And there is the if condition that could have been several steps earlier in this process, checking, are you on an iPhone? And if so, what does it do? Window.location equals m.harvard.edu. So don't do it this way. Okay? There's many other ways to do this. And the irony is, I think the site is probably doing something quite smart, which is dynamically querying what kind of device is this, because those user agent strings are changing constantly. Even though we only know about Chrome and IE and Safari and the like, there are a lot of other browsers out there, particularly in mobile devices and other manufacturers. And the version numbers are changing. Those strings are changing. So it would kind of suck if you built a website that's breaking constantly for some of your users. So what has become popular is these so-called web services, third-party servers that you can query and say, here's a user agent string. What are the device's capabilities? What's its screen size? What is the browser type? What does it have JavaScript enabled or support or the like? Well, that might very well be what they're doing. But this is sort of the wrong decision point at which to do it. The right decision point would have been to do it in the context of the server with the initial request. But this is guilty of the lack of feature I criticized earlier. This would be a better example. So what am I doing in version 2 of this? Well, I'm actually concatenating onto the end of the mobile domain name the file that the user cared about in the first place. So this is that one-line fix that a lot of sites on the internet could definitely stand to benefit from in terms of experience. So when the time comes, if you're curious as to how to dynamically access browser information, frankly, if iPhone or iPad or iPod is a pretty decent heuristic, at least to get all Apple hardware, if that's what you're targeting. But realize that Wurfel here is an initiative on the internet that has a bunch of open APIs that you can query in order to answer those questions. But there is a gotcha. So what is worth bearing in mind about HTTP headers in general when it comes to relying on them? Yeah. So they can be faked very easily. In fact, as we'll encourage in this course, faking them within Chrome or some other browser so you can trick the server into thinking you're an iPhone so that you can actually test on your desktop browser. They can be scrubbed altogether for people who are particularly concerned about privacy. They might have some special software that just scrubs all sort of identifying information. So it's not 100% reliable. So in that case, you sometimes do have to resort to JavaScript to figure out what the screen size is or what features the browser supports. But typically, at least detecting things server-side is one place to start. And then falling back on JavaScript is a reasonable next step. All right, so the appliance we'll allude to in more detail in the first project spec. But let's get a sense of the technologies that we'll be taking for granted, all of which are pretty representative of what's being used today for web and mobile software engineering. So LAMP is just a silly acronym that was applied a few years ago to describe 4 things that already exist: Linux, Apache, MySQL, and PHP. So you will very commonly see LAMP on someone's resume these days, and it just means that they know or have used that particular combination. So it's actually fair to say that the Cs50 Appliance has a LAMP stack, which just means it has at least those 4 things installed. Now, why is this interesting? It's just super common. All right? One of the reasons we did use PHP and MySQL and Cs50 is because, 1, the learning curve is relatively low, certainly coming from a language like C. 2, it's also just omnipresent. And even when you pay for a third-party web host or use someone like HCS, just servers very often have not only PHP installed and ready to go, it's also relatively easier to set up than something like Ruby and Rails or Python and Django, which are getting easier, but PHP just tends to work because it's been popularized for a little bit longer. So with that said, this is what the appliance has installed in it. What kinds of things might you use? So for the course's purpose, you and your partner can use pretty much any tools that you prefer. We will encourage or at least introduce you to some things that will hopefully help take you to the next level. gedit is probably not where you should stay your whole life. And a few years ago in 50, Nano, hopefully you're not still in Nano. But if you are, we'll fix that now. So among the most popular, just so that as part of this class you guys get exposed at least to some of the things that everyone else seems to know, or in a Facebook interview they would just kind of expect that you know. Emacs is particularly popular, especially among computer science type folks. Gedit is actually not bad. It is definitely better than something like notepad.exe because it does have syntax highlighting, auto indenting, so it's kind of a miniature source code editor, but it's still pretty simple and limited. In the Windows world, Notepad++ tends to be what most Windows users swear by, though there are alternatives there. Text Wrangler on the Mac, and Vim. These are all free options, and there's many, many other commercial options. So what's an IDE? Yeah. Yeah, integrated development environment. And what does that mean? Perfect. Yeah, it's like one application that tries to do a whole lot really just to save you time and sort of keep you immersed in one particular environment. So you compile in it, you write code in it, you might run tests in it, you might save and revise your code within it with source control. And just out of curiosity, how many of you have regularly used, for either a semester or a job, an IDE? OK, so most folks in this room. So for that, for the course, you're welcome to use most anything. What we've installed, what you will install via command in the appliance is one called Netbeans. And this is one of these religious things. Eclipse is another big and very popular one, as I mentioned here. Genie is now in the appliance as well. It's sort of a lighter weight version that we might use in 50 next year instead of gedit. Komodo Edit on the Mac. Aptana Studio is really just Eclipse customized for PHP. Long story short, you're welcome to use most anything you want. But if you're coming into the course with a little less comfort, a little less experience, we would recommend using, for instance, Netbeans because it does everything we'll need for the first two projects, and its learning curve is relatively low. My only personal gripe with Eclipse, for instance, over the years, it's just very memory hungry. And I feel like it's the only IDE that consistently crashes on me. But this, too, very religious. So this is a fun debate you and your partner can have. And that's also by the design of the course. All right, so another little overview of things that will make our lives easier that we'll soon see in action. So thankfully, we don't need to implement the first of mobile websites from scratch, writing all the CSS yourself, trying to mimic the look of an Android device or iPhone or Windows mobile phone. Very much in vogue these days are these frameworks, which are typically CSS or JavaScript based that just make it much, much, much easier for you to just make a site that's optimized for a mobile device where you can focus on the content and the interesting features and not the stupid windows and icons and buttons and things that maybe you would like to focus on as a project at building your own library, but they're incidental to actually building an application. So the one we'll recommend and require that you use for the first project is Jquery Mobile, which just reached version 1.0 status. Sencha Touch is fairly sophisticated. Its learning curve is actually much higher. JQ Touch is still kind of lingering in this beta state, but they all do ultimately the same kinds of things. So let's get a quick sense of what they will now facilitate. So I'm going to go back into my appliance here. Let me close these earlier tabs. I'm going to go into the CS164 directory, and I just wanted to make up this weekend a very simple mobile website for the course. And I used a little bit of HTML5, which really boils down to using this tag here to make it mobile friendly, and then the usual suspects for a couple of links to lectures and the syllabus. So let me go over to my browser again, go into my CS164 directory, HTML, voila. So this looks pretty simple, and indeed it was meant to be. If I pull this up in a simulator, it's going to look just as simple, but thankfully readable. And it's a mobile website, right? You can kind of touch that link with your finger. It's not ideal, but it's not super small. And if you really want, and if you've not used the simulator before, if you hold down Option, you get little two fake fingers that allow you to pretend to pinch on the screen. So I could pinch on the screen and touch these links just fine. Right? But this is not really what you would expect these days. And it'd be nice if we could just say, make this look mobile. Right? And you can with these frameworks. So if I instead go back into my CSS directory, let me first try to do it myself. Let me go into this file here. I'll open it up in gedit. So this is the CSS version that I made from scratch. And let me open up ios.css. And the details here are not important, but notice that I have stylized tags like the h1 tag, the li tag, the anchor tag, and so forth. And I took some time to come up with a border bottom, or someone spent the time coming up with a border bottom and color and display and padding and so forth, to give us like rectangular buttons and clickable things on the screen. So if I now include that CSS file in my same kind of HTML file, actually I'll do it in a the simulator so it looks a little more compelling. All right, so it's simple, but it's a little sexier, right? It says CS164 at the top, kind of like an iPhone app. I can click Lectures. It changed, click Lecture 0. So it looks more reminiscent of an iPhone app. But what did it not do? Or what is it not doing that for those of you with iPhones might? Yeah, so the transitions were kind of like old school HTML, just page reloads, page reloads. It's not the sort of elegant right to left side swipe. What else is sort of not quite like a native app also here? Yeah, so you kind of see that you're obviously at cdn.cs164. So you have this address bar, which definitely kind of takes away from the UI. And frankly, the top of the UI is a mess now with the clock and the lecture 0 and the URL and then the lecture 0. So these are the kinds of things that people find fault with when it comes to just choosing between mobile websites versus native. So let's try to do a little better. Let me instead go into my third version of this, which is in the framework directory. Just one file this time, index.html. But notice what I've done here. So let me zoom in here. Just one file. Demonstrates jQuery mobile. So I've included a couple of things. So those who've played with CSS and JavaScript a lot know you can include files up top like that. So I've included those as per the documentation on jQuery mobile's website. And if I scroll down, now this library is actually taking advantage of some very HTML5 specific features. One of the nice things about HTML5 is that by design, you're allowed to have any attributes you want on elements that begin with the word data, followed by a hyphen. So maybe not the best of names or a little verbose, but it allows you to have arbitrary attributes on your elements that will not result in validation failing, if you care about validating against like the W3C's validator. So what this jQuery mobile library is doing is it's using this data prefix to define a few conventional attributes that allow you to semantically tag the data in this file with its meaning. So apparently at the top here, they've decided that if you use a data role attribute, you can say that the following division of the page, this block level element, is a quote unquote page. And we give it an ID as usual. But then nested inside of that is another div. Its role is header. Beneath that is another div whose role is content, and so forth. So HTML5 and this library are really embracing this idea of using this additional metadata to ascribe some meaning, semantic meaning, to the various chunks of data on the screen so that now the framework can render those things a little differently. Now, you might use CSS classes for this, and you could. And historically, this is what people would do. They would have a .content class or .header class. But that was kind of the overuse or abuse of that feature of classes. This is really meant to describe roles. So what's interesting about this is that here's one page inside of this big div, and that looks like it's going to be my home page, lectures, and over here, a syllabus link. But if I scroll down in the same file, notice now that there's another div whose role is also page, and its title is apparently lectures, and there's lecture 0 and 1. Scroll down further, here's the third page, yet still inside of the same HTML file. So in short, because I had the foresight in this example to know what the entire UI is, I can actually construct it all within one file and then kind of link those several roles together by way of links that are not necessarily full paths. So this is obviously to a remote server at this URL. But notice up here, these are all relative. So HTML5 and specifically this library are leveraging fragment IDs, which normally jump you from one point in the page to another. So this isn't going to be some big hideous page that has stuff up here, then down there, as it would in the normal desktop web. It's actually going to be displayed a little more like mobile experiences we've had. And this thing here, this is just a skinning theme. I don't know why they chose A, B, C. The sort of worst example of like coming up with variable names, but A and B and C and D and so forth are all different skins that you can apply to this library. So let's go into the simulator and pull up this third example here and go into, let's say, framework and that single file. Uh-oh. I broke something. That's embarrassing. OK, let's go over here. So that it doesn't look totally horrific. Lectures 1. All right. So here's my new simulator. OK. I'll fix that during break or after class. OK, so actually, I'm actually kind of serious. Like, it's kind of annoying to test out your code for the next several weeks and just using a little simulator, or God forbid, your actual phone on 3G or even Wi-Fi. You can actually use a desktop browser and optionally fake your user agent string, if that matters to the server, which often it does not. Or you just resize the window, and you'll see in the first project spec, there's nice little Chrome extensions that let you click a button, and voila, Chrome is now resized to mimic a phone, as I did manually here. So now, notice I get a little nice hover effects, which is inapplicable when you're actually using your finger. But let me click this. And now we're getting the sliding effect. Right? I can click slides, and it's actually going to pull up the PDF, which would render then in the phone or the simulator in that case. And if I go back, it's pretty good about sliding. But feels like it just slid in the wrong direction. When I click back, I still see the address bar up top, and I would in the simulator. You can hide the address bar. Some sites do this, whereby if you pull up the mobile website, you don't see the address bar by default. And that's really because of a JavaScript hack, whereby if you're familiar with the notion of the scroll top property of a page, which says where should the scroll bar start, what a lot of websites do is they just, with JavaScript, say move the scroll bar 20 pixels, and there's your hidden address bar. But it's still actually there. Yeah?
Shouldn't that define an XML schema to pass validation, not rely on this data?
Say that once more?
Why doesn't that feature rely on a new XML schema to pass validation rather than relying on the data that attribute?
Well, OK, so why not use an XML schema or DTD to actually validate the HTML markup? The short of it is that browsers browsers only care about adherence, in theory, to a minimal set of standards. The data hyphen roles are meant to be unique to any old website. You could require that individual websites produce a DTD or schema or RelaxNG schema for their HTML. But I think the world just doesn't care enough to actually do that. I mean, I think that you could. You absolutely could. That would be a much more rigorous design. But I mean, we live in a world where they don't even require us to close some of our tags. And so that's kind of the mindset, I think, in general. Other questions? All right, so better, and if you're making a mobile website, and such as the one I demoed last week, the CS50 Fair mobile website, we did that little trick where we moved the scroll bar up so you didn't actually see the address bar by default. And it's better than having to roll all of those features yourself with CSS and JavaScript. So it's a way of getting started typically quite quickly. So the little tour there of frameworks. All right, so what about tools? So version control. So this is something we kind of sort of use in 50. In higher level classes, hopefully you've made more frequent use of this. And for this class, you will necessarily have to use version control. Specifically for standardization's sake, we'll use Git for the class, which alongside Mercurial and Subversion is kind of on its way out, are really among the top contenders these days. They're pretty much Git. Mercurial, Bazaar is another one. These are known as distributed version control systems, which are a leap beyond things like SVN, CVS, and older ones. Long story short, if you've ever used SVN or similar, these typically rely on a central repository. So you and your partner and your other colleagues all have local copies of some website or some program. And when you want to share that code or save that code for perpetuity to the central server, you quote unquote push it to or commit it to a remote server. The downside here is that as you're making local changes on your own laptop or desktop, if you're using something like SVN, you can push to the remote server, but you can't maintain versions in the same way in your local directory. So thus were born distributed version control systems like Git and Mercurial and others that allow you to not only commit your code, save different versions, differentials, as often as you would like in your own local directory. They also then let you push to a similarly designed central server, but you can also pull directly from your colleagues and such. So particularly in large organizations where it's not just you and a partner, it's you and 10 people, you and 500 people, you can actually share collaboratively and merge other people's code, source code files, into your own work, give them your work, and so this is where things are going. So just to paint a picture of this, and we'll spend more time on this in labs, there's a few pieces of jargon that underlie most of these systems. If you think of this as a timeline going from top to bottom, on the right-hand side there we'll call the master branch. The master branch is the product that you care about. And every one of those little blue circles represents an interesting commit where you rolled out some feature and pushed it into the central server. But along the way, you might want to experiment, or different people might want to work on different things. And it's kind of a bad thing if everyone's working on the master branch, because if one person has a bug, commits that bug to that central branch, who does it affect? Absolutely everyone. So the idea of these systems is that you can, quote unquote, branch off of the main branch and have your own little branches depicted here as little yellow dots along this line that let you work on individual features and only merge back from left to right into the master branch when you have rigorously tested your code, it's been reviewed by some number of colleagues, and you're sure that you're not going to break the entire website. So companies like Facebook and others that are actually constantly pushing out changes to the website do engage in processes like this, where you work on your own branch, and you only are allowed to merge it into the master branch once you know it's not going to take down all of Facebook. That's at least the theory of it. But I'm sure all of you have tripped over bugs in Facebook and the like nonetheless. All right. If you really want to wrap your mind around this, gets sophisticated over time. And when there's more than just you and a friend, you can divvy things up, as this tutorial here has. We'll post this link online on the slides. But you can traverse a tree that is your source code repository. So what does this mean in real terms? Well, what it means, when you first sit down to do a project for the class, working with your partner, both of you, or well, at least one of you initially, will create an empty directory, maybe start writing some code, but the moment you're ready to share that code or commit it to some central server, you're going to run a command like git init for initialize this directory. What does that do? It stores an invisible directory called .git in your current directory that where a lot of metadata is stored. All of the differentials between files that you've saved. You can then add files to that repository. You can commit, which means save files to that repository. You can push files from your repository to a remote server. Conversely, you can clone the repository. In 50 this past year, some of you might have used the clone command to download lecture examples or pset distribution code. And you can also pull from another friend, which means don't make a copy of it. It means integrate everything into your own code. So for the course, there's a bunch of options out there. We've decided to use Bitbucket because, one, it's free, and two, because they give you unlimited private repositories. So you might, the biggest player out there is GitHub, which charges a fortune to actually have a non-trivial number of private repositories. Private just means only you and people you authorize can access your code. GitHub is meant to be more social, so if you've heard of this company, they're wonderfully popular, especially for open source projects. But by default, all of your code is open, which means when you push to the central server, it means the whole world can then pull or clone it themselves. Not ideal for a class, not ideal when you're collaborating on something of your own design. Bitbucket, though, is similarly free. It's because they want you to buy their non-free products, presumably. But they provide you with unlimited code repositories, so private repositories. So the first project spec will walk you through the process of setting this up. But what this is going to mean is both you and your partner will have one of these repositories. One of you will set up the project initially, and then you'll be able to collaborate with each other by way of committing code to the central server. The staff and in the future classmates can actually see your code and actually browse it on this website as well. They have nice little wiki and bug tracking features of it. So in short, we'll use a real world source code repository so that your experience is as real world as possible. Yeah?
Does that mean we have to use Bitbucket for all our collaboration?
For the course, yes. You can use, in theory, other repositories, but it's going to have to eventually get pushed into this, which is fine, because the whole idea behind Git is that you can actually push to multiple repositories if you would like. All right. That was a lot. Let's take a 5-minute break. All right, so we are back. So a word on the first project. We'll touch base on this at the very end of today. The specification will go online tomorrow. And so that we realize folks have enough time to make sure they have a partner and such, we'll actually have the proposal due this Friday instead of this Wednesday. So website and syllabus and online have been updated. The proposals are fairly low key. For the staff assigned projects, the proposal will really boil down to reading the spec and thinking about it and having a brief conversation with your partner about who is going to do what. Figuring out, oh, I'll do the JavaScript, I'll do the PHP, or I'll do the database schema, or also just navigating those kinds of issues. For the students' choice projects, the proposal will be more like a traditional proposal where you have to get together, talk, and figure out what it is you are going to do. So this is a typical release cycle. It fluctuates a little bit because of vacations and whatnot during the term. But next week, for the design document and style guide, you'll be expected, using your Bitbucket accounts, to actually put together both a style guide for this first project and a design doc. what does that mean? So a style guide will be akin to what we show in Cs50, where you make some decisions, maybe arbitrary decisions, as to what your indentation is going to look like, where you're going to put spaces. All of the things that we put into the style category in Cs50, you're going to have to argue about and have some really stupid arguments with your partner as to which is better, 2 spaces or 4 spaces, or tabs, or putting the curly brace on the same line or different line. We don't care what the outcome is so long as your code ultimately is uniform. And so among the things we'll be looking for is adherence to your own set of standards. So that's always a fun religious conversation to have. The design document is the more intellectually stimulating part of that conversation you'll need to have. And typically this will involve figuring out what are your database tables, if applicable, going to have to be. How you're going to normalize the tables and put IDs in one field, foreign keys in another, and the like. How are you going to go about designing the PHP code and or JavaScript, really fleshing out in detail in advance how you're going to approach the project so that ideally after that Monday you and your partner can go off autonomously, pretty much build some things independently, having made promises to one another as to what you'll build and how you will interface with one another. So we'll talk this today and Monday and beyond on how to sort of formulate those kinds of conversations. And the idea is that hopefully they will get easier and better over time. If come this weekend you sort of are standing at a chalkboard or hanging out with your partner and you're like, where do we even begin? Like, that's the perfect place to begin a design conversation. And I promise you by Monday you will have figured it all out. So thereafter, we'll do a beta version of the product by that Friday. Thereafter will be an opportunity for the staff and classmates to review your code and actually comment on it. And then finally, a couple weeks after this whole process, a formal release date where you ship that code. And it will look amazing at that point. All right. So object-oriented programming. This is something that comes up in CS51 and in some other higher level classes. For those who have less experience with this or none whatsoever, realize that for larger software projects, this is pretty integral typically to a design, if only because it allows you to standardize what each of you are working on in such a way that your code bases that you each write separately can talk to one another a little more cleanly than they might using other techniques. That's not the only way to write code, but it is certainly very popular. So you might recall either from this past year, 2010 or 2009 in CS50, we had the Cs50 Finance assignment, whereby we gave you a bit of skeletal code for talking to Yahoo Finance. And if you called that lookup function, that actually took as input, for those unfamiliar, a stock symbol and queried Yahoo via HTTP and then returned to you, the developer, a object, a struct, really, containing a whole bunch of fields. And in 50, we kind of wave our hands at these details and we say class is a struct, don't worry about it. But there are some interesting details that we gloss over. So classes have more meaning than just structs. Whereas a struct in C is just a container for data fields, a class or an object can have what? So methods, or otherwise functions, sort of inside of the object that perform some kind of operations related to that object. So rather than pass pieces of data into functions like we talked about on Monday with sorting functions and searching functions, you just take the object in question and you call its own sort or search method. So it encapsulates functionality and data a little more cleanly. In CS50, we just say public, 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 public. And this is really not the right way to leverage classes, because in most languages like PHP and Java and others that support the notion of visibility, you can use special keywords like public and private and sometimes protected, which specifies who can actually access these fields. When you say public, you can probably infer that that means anyone can access it. So in PHP, that means you can simply say something like, let's say S for stock, arrow price, and anyone that has included this file in their own PHP code, upon getting back a stock object, call it S, can access price. By contrast, if in 50 we had made all mentions of public there private, you could not have done this. So the lookup function in pset7 could have handed you back this special object, called it S, that's a stock object, but the data is inside of it. But if it has no public data fields and no public methods, you have no means of getting access to that information at all. So typically what you would do when designing something like this, if I do a quick copy paste, open up a text editor here, and let's say paste this in here. So if I were instead to do a global find and replace here, and let me change all mentions of public to private, So this is not a useful object just yet if I can't actually get at the information inside it. So what we'll see in PHP, as in other languages, is that you can actually expose this information via methods. They're often called getters and setters. Some languages take this to an extreme. But you would typically do something like public function, let's call it getPrice. And then down here, we would do something pretty trivial, potentially. Let me scroll up a bit more. We could do something super simple like return this arrow price. So as you might have guessed, this is self-referential. When you're writing code inside of a class, this refers to the object currently in question, so the $S variable. So arrow means dereference it and give me the price field. So the getPrice method here, can access the price field because, even though it's private, because the code in question is inside of the class. So by contrast, in Cs50 pset7, you, the person using the lookup function that we wrote for you, could not use syntax like this. But you could, if we rewrote the class, do something like this. $arrow get price. And then you could store that value in, say, a variable called price. So this is a simple example. And it's actually not compelling, because what is the value of this? Right? I've really just made more work for myself, it seems. Yeah?
Why can't you just do return price?
Return price. So if you did return price in, so this is not like Java. In the context of PHP, this would assume it's a local variable called price. Good question. So this is not all that compelling, admittedly. So why even bother?
This way you can change the price from outside.
Yeah, so that's actually pretty compelling, right? Especially in a large system where you might be passing variables around a lot, and you're not immune to writing buggy software. You don't want to accidentally put something like $S arrow price, and then just by accident or copy paste fail, you do something like this somewhere in your code where the assignment's actually on the other side. What you've just done now is mutated the contents of that object, even though it really should be immutable. The price was that at a given moment in time. Yeah. Perfect. So if you want to change the underlying implementation details of a price, maybe you want to break it up into dollars and cents and have two different fields, maybe. Or maybe for something like, let's pick another one. There's two variables inside of this object, apparently called high and low. You can think about arithmetic operations that might be useful to build into the class so that you can ask and answer queries like public function get change. Right? And now, even though this is a super simple operation, it's definitely arguable that return, so this minus high minus this minus this arrow low. So you can also embed functionality that, maybe you need to do some intelligent logic there where maybe you have to do the high and the low at different times of day or something. So the implementation details for our purposes are meaningless, but the fact that I can hide them from you and encapsulate this kind of information and functionality, only exposing to you what we'll call an API, application programming interface, is quite compelling. Because in the context of even two people, a partner and someone else, I can commit to providing you with a method called getPrice. I will promise you that for now this will return a floating point value, even though that's not maybe ideal for money. But how I'm going to implement that, you don't need to worry about. And in fact, I might change it on a daily basis as I get better and better at programming, so long as I ultimately adhere to the API that I've committed to providing. So among the conversations that you'll have with your partner are going to be things like this. I'm going to implement this class, and I'm going to provide you with these methods, and you might have no idea on Sunday night how you're going to implement those or what the complexity is. But so long as you agree on this contract in advance on this API, then your partner can start writing his or her code just knowing that those methods will exist. And in the short term, frankly, your partner could make a very fake stock class that just always returns $1, and just let you fill in the blanks later. Yeah?
Are we extending classes from frameworks, for example, like Codeigniter?
Good question. We will be. So over the next short while, we'll actually take a quick tour of how we could do this on our own and building up ultimately to a framework that will have both its pluses and minuses. But any questions on this idea of, one, an API, and two, this idea of encapsulating functionality and data inside? Okay, rarely, at least when building larger systems, rarely should you need to expose your object's properties as public unless, as in the case of 50, it was just the expedient solution. And we weren't really working in that case with anyone else. All right, so let's take a look at where we're going with this. So this allows us to have this conversation about this, MVC, Model View Controller. So this is just a paradigm. It's kind of an oft-used buzzword, but it's very much in vogue, certainly for web development and even for desktop software, because it allows you to kind of factor out different functional components of an application and more easily update various pieces of it. So here we have a little picture of someone's computer, and this person is visiting, let's say, a website for now, and that website is implemented in the form of a file called index.php, which is typically the default. So we're going to start calling index.php a controller. Meanwhile, if this website has some kind of database for stock prices or a user's database or the like, I'm not going to write any of my MySQL underscore queries inside of index.php anymore. That was just too messy, right? In 50, especially pset7, all of this functionality is commingled, but now we're going to start teasing things apart and drawing barriers between different types of code. So my controller is going to do that. It's going to control the whole application. So when it gets a request, a get or a post or similar, it's going to then decide, OK, to satisfy this user's request, say for the home page, I need to go get a list of users, or I need to go get this user's portfolio of stocks. But then what the controller is going to do, once it has that information, an array of users, array of stocks, it's going to pass that information to an entity we'll call the view. And maybe this is a desktop view, maybe this is a mobile view, but it's a different chunk of code whose sole purpose in life is to render information that's already been perhaps dynamically generated. And then finally, does the view get returned directly to the end user. Now contrast this. If you did take Cs50 in the past few years with pset7, Cs50 Finance, contrast this with the following scenario. If in the middle of that week that pset7 was in progress, we said, oh, by the way, your website should also be mobile friendly. Right? Like, it's kind of hard to do that and still maintain the same user interface you had spent that night or couple of nights working on, because you kind of have to design for different parameters. Smaller screen size, you need bigger icons, you really need two different user interfaces. But because all of your code for that pset in particular was probably hard-coded in quote1.php, quote2.php, by1.php, by2.php, you would have to pretty much copy and paste all those files, maybe move them to a separate directory and just call it m.pset7.com or whatnot, right? You couldn't really just tweak the aesthetics. So one of the compelling features of MVC is that if the design requirements change overnight, or you want to support some brand new iOS device that just got released whose screen size, like the iPad, is a little different from every former iOS device, the only code you need to change in theory is the red box, the views. And what are those views? They're essentially glorified HTML files with placeholders. So you would write your HTML, your CSS, maybe some JavaScript, but in separate files, and then you would plug in variables. So you can genericize things like your page's title and headings and footer, and you can factor these out into what we'll generally call templates. So we can now start to keep things much more cleanly designed. And the upside here, too, is that you can say to your partner, all right, you know what? I'm going to do the controller and view, but I need you to implement a users class, a stocks class, and some other class. I need X and Y and Z as methods, and for now I'm just going to assume they exist, because when I get requests from users for his or her stock portfolio or a list of users in the system, I need you to answer those queries for me. So you can now start drawing lines. Even if you don't have a partner, you yourself can compartmentalize functionality in this way. So we'll see in a moment a fancier framework called Codeigniter that will make this both easier and harder for us sometimes. But let me go ahead and open up the following. So I'm in the Cs50 Appliance right now. And just for those on the fence about what they'd want to use, I've pulled up Netbeans, which comes installed when you update the appliance for CS164. I'm going to go ahead and say New Project. And just to give you a sense of what these things can do for you, I'm going to choose a new application with existing sources. Let me click Next. I'm going to fill in this blank, so sources folder. I'm going to choose example 0 that I brought with me. I'm going to specify PHP version 5.3, which is the latest. The reason the IDE cares is that there are certain language features that then it can help you with, for instance, autocomplete and syntax highlighting and the like. Where's the project? What's the project's name? 0, that's fine. Next. Now, this is where these tools get more interesting, whether it's Eclipse or in the future Xcode or the like. You can configure them to automate a lot of tedious tasks. Right? In 50, some of you might have been in the habit of coding on your own computer or in the appliance and then uploading your files to the cloud. But every time you did that, you had to drag and drop files or use SCP or SFTP. Imagine a world in which you just click a button and all that happens for you. These are the kinds of things these things can do for you. So we can say run this code on the local web server. Let me go ahead and paste in HTTP. Let me borrow the URL here that I know it's going to end up in. Go ahead and paste in that URL, finish, and voila, what you get, for those familiar with gedit, is sort of a glorified gedit interface, but with some more buttons and menu options at top that will facilitate coding in this environment. For instance, let's see if I can do this on the fly. If, for whatever reason, I wanted to put a PHP chunk of code here, and suppose I wanted to do, let's say, x gets preg, all those functions you kept having to Google or look up on php.net, you get things like autocomplete, which if you've never used this, it's kind of useful. Now, I say that rarely using this myself, since I just kind of type it in. I use Vim usually. But especially from a learning curve perspective and also just a time-saving perspective, being able to do tab completion and the like for function names, being reminded exactly what's expected, it's kind of compelling. So realize if you're still living in a nano world or even gedit world, use the class as an opportunity to either try Netbeans or some other tool that your partner convinces you to use instead. All right, so what is this example? Well, let me go in here. And this is actually just a very underwhelming course website that we just saw before. And in fact, all I did to make this PHP is I changed all the file extensions from HTML to PHP. But underneath the hood, we have the exact same files. If I go here in Netbeans and open up index.php, after removing the silly code I just wrote, that's all this is. It's really just HTML, and I called it PHP. But notice it's linking to lectures.php. What's lectures.php? Well, that's this file here. OK, really uninteresting. It's just HTML. But let's now use this simple website as an opportunity to start engineering this site in a better direction. In fact, what are some of the improvements I could make quite quickly, bearing in mind that at the moment we have index.php, lectures.php, and lecture0.php, and lecture1.php. How did I create lecture1.php? Yeah, I did. I copied and pasted it effectively, or the cp command, right? And what am I going to do next week? Cp. What am I going to do the week after? OK, there's got to be a better solution to that problem already. Moreover, what is probably shared among all of these files? So style sheets, CSS. So we were pretty good about that. At least we don't use CSS here, but even in 50, we at least encourage, like, factor things out into a .css file. But what more could we factor out? Yeah.
The menu bar.
Yeah. So we have the menu bar, the title of the page, right? The heading tag. There's a lot of common functionality that if you flip through these in more detail, the website looks almost identical on every page, right? And I can see this if I just click on lectures. Looks pretty similar. Lecture 0 looks pretty similar. Let me at least start factoring out the minutia of the page. So we did use require, or require once in 50 for PHP stuff. Let's see if we can't leverage that as a simple mechanism for cleaning up this code. So let me switch to a command line just so we don't have to create a new Netbeans project just for every one of these simple examples. And let me go ahead and do this. So this now is version 1. Up from 0. And I propose that this is a step toward what we called an MVC architecture, Model View Controller. Now, it's not perfect yet. And in fact, none of these will be perfect ultimately. But what have we done that's at least compelling here? I factored out the common code up top, and I factored out the common code at the bottom into two files apparently called header.php and footer.php, so that if I now open up header.php, that's all it is. It's pretty uninteresting, but at least I never, again, have to copy and paste that same code. How easy is it now to just change the title of the web page? It's super simple, right? I change it in header.php, and that's it. Every other page changes automatically, because if I look in, let's say, lecture 0, it's the same idea. I have some comments up top, but I'm requiring the header, I'm requiring the footer, and then I just have some raw HTML. So once you combine all three of those files, you have a complete whole. Now let's push back and start finding fault with these things already. What's bad about this design? Yeah?
You can have different titles on different pages.
Yeah, I kind of painted myself into a corner. The title of every page is now CS164. It's no longer lectures or lecture 0. I had to give that up, but hey, look how quickly I can update the site now. Other pushback. Be really nitpicky here. What have I introduced that I didn't, a price I didn't have to pay before? All right, so think to pset 6 if you took 50. Like the dictionary, like what did you try to avoid in the dictionary pset? Sorry? Well, actually, hard coding in that pset's pretty good. It tends to save you time. But other things. What costs time? Function calls, right? So function calls involve some modicum of time, right? You have to build up the stack. You have to tear down the stack. So there's at least some number of milli or even nanoseconds involved in at least calling the simplest of functions. And what am I proposing? Hey, you used to have all your HTML in one big file that's super simple to serve. Why don't you first call 2 functions, combine the 3, a la string concatenation, and then send that to the browser? So I have introduced a bit of overhead here. Now, my pushback to that pushback is, don't worry about that for now. Frankly, caching will solve a lot of our problems, as we'll talk about later in the term. And by caching, I just mean, all right, sure, you have to do this. But the first time you do it, just save the results in a raw HTML file or in a database called memcache, which is running purely in RAM. Facebook uses this quite a bit to improve performance. So we can ameliorate those concerns as well. But that's one pushback. So let's see if we can do better. Well, let me go into version 2 of this. And in this version, what have I done that's a little differently? Well, rather than just require a file, and henceforth, let me call header.php and footer.php templates. They're just sort of boilerplate code that I want to use almost everywhere. So I've obviously changed the call from require to render header. Now, render header is not a PHP thing. I just invented it. And in fact, it's defined probably in a file called helpers.php. So I'm still requiring, but that's because I want access to some global functionality, functions I've written, like the lookup function from pset 7. So require once helpers has defined in it 2 functions called render header and render footer. So this is an improvement, I would argue. Why? Yeah. Yeah, so now I can apparently dynamically insert a different title. Why? Well, recall that PHP supports associative arrays, aka hashes. And so this hash allows me to pass in a key of title and a value of CS164 for this page. The footer is just some silly copyright notice or body tag and HTML tag closing. So I don't really need any arguments there. But this is a little nicer. So let's look at helpers.php. So helpers.php is actually pretty simple. So render header takes an argument. Know that if you don't know already, PHP can have default values. So if I don't want a title, I can just pass nothing, and the interpreter is not going to complain at me. Does anyone know what the extract function does? Yeah.
Takes all variables from an array and just brings them to a global namespace.
Yeah, exactly. Or to the local function namespace. Yeah, exactly. Extract takes an associative array that's got a whole bunch of key values. X equals Y, Z equals W. And what it does is it extracts into the stack frame in question variables X and Z and assigns them values Y and W so that now you can just say $X, $Z as usual. So why do I care about that? Well, the next line of code here is to require header.php, which is almost identical to before, but notice what I've done up top. I've generalized the title as coming from a variable called title. Now, I'll pick on my own code. I don't really have any error checking just yet, right? If you don't pass me a title, this is going to give me an undefined reference to it's going to trigger a notice because that variable might not exist. So we can do better, but at least I had the foresight to remember this oddly named function to escape my inputs just so that a user doesn't intentionally or accidentally inject some JavaScript code or the like, which can typically violate someone's privacy. All right, so that's a little better. Let's see if we can't do even better than that. So in version 3, that was kind of a waste of code that I just wrote. Render header, render footer. Why don't we generalize the idea of templates themselves? Let me define a function called render that takes 2 arguments, potentially. The first of which is the name of the template that I want to render. The second of which is an array of key value pairs that I want to insert into that template. So now I can use the same function at top and bottom. And if I look now in helpers.php, I have just one function here. I also have this. So anyone recognize this kind of syntax up top? It's obviously a comment, but I seem to be using the same style. Yeah, so this is something we'll preach and ultimately require for your own code. So there's different tools that do this. And if you wrote Java code in high school or even here, you might be familiar with JavaDoc, which is pretty much identical to this. That kind of became the de facto standard. And JavaDoc, or in this case PHPDoc, is a set of conventions that you adhere to in such a way that when you run a command, PHPDoc, on your code, or in the world of Java, javadoc on your code. It will read through all of your .php files, look for all of the comments that are structured exactly like that, and then generate for you a special web page or suite of web pages that document all of your functions' names and return values and arguments and comments and all of that, so that you yourself don't have to. You just comment your code along the way. You use these little tags like @param to say this function takes a parameter, its type is array, it's called data, and then I can even put some words there if it's not wholly obvious, key value pairs, and that will automatically get inserted into my documentation. And certainly working with other people or producing code that you want to allow the rest of the world to use, allow open source, my God, this is what you can provide your partner with. You can start, and I do this myself when starting projects, you start by writing your PHP files and just writing the functions' names and signatures, so what arguments they take, and then you just do open curly brace, close curly brace, and inside you write / to do, right? And you come back to this later, but you document it above. Then you run a command like phpdoc, and voila, you show your partner, here's what I'll implement for you. It might take you 2 weeks, but at least you've agreed on these conventions early on. So getting into this habit is now useful not just for you, but also potentially for others. All right, so that's a little cleaner now, and I'm doing a little error checking. If the file exists, go ahead and require it. Otherwise, don't do anything. But let's take things up a notch further. Let me go into index.php in version 4. And what have I done here? So there's only one material difference in this file. It might be hard to spot, but does anyone notice what I did differently? Yeah, includes. So we kind of used this convention in CS50's pset 7 if you took that, if you did that pset. But we didn't really preach this philosophy. But it's definitely important when it comes time to actually writing software that real users are going to use. And by that I mean this. Let me go ahead and do ls in this directory. And notice that I've cleaned things up a little bit, just like pset 7. Rather than put all of my PHP files in the same folder, I kind of want to isolate them so that the related files are all clustered together in a folder. And by related, I mean things like the templates. Like header.php, footer.php is never supposed to be visited directly by a user. So why is it in the equivalent of my public HTML directory, right? The user shouldn't even need to know that exists. And frankly, I don't even want him or her to just guess by typing in random URLs that there might be other files there. So I might want to put it in a directory and then somehow set permissions on that directory so that the rest of the world can't even access it. So this example here, 4, is a step toward that, where in templates, I've put precisely those files, header and footer.php, and includes, even though there's not much there, I've put helpers.php. So it's a step toward better organization. But find fault still. What's still problematic about this directory structure? Yeah?
Every time you want to make a new lecture or add one, you have to copy lecture 1 still or lecture 0.
All right, good. So we still haven't solved that original problem, which is there's going to be some copy and paste next week when I make lecture 2.php and lecture 3. So we can fix that. And then 2, just this idea of security, right, really includes and templates. They don't need to be web accessible. The contents of those files do need to be. But their file names don't need to ever appear in URLs. So ideally, where would I want to put includes and templates in terms of my folder structure? Above, right? MV something ... Like get it out of there, right? And this is a principle that's all too commonly ignored, especially with various open source projects, and even Codeigniter, which we'll introduce in just a bit. These open source tools, MediaWiki and the like, which are meant to be easy for users to use, and they typically say, OK, download this zip file, unzip it, put it in your public HTML directory, and you're on your way. The problem then is that all of the logic of the program is publicly accessible, and things like config.php, which we had in 50 for pset 7, I mean, God forbid you screw up the web server's web configuration, even for just a few minutes. Maybe your PHP files will just be completely publicly accessible. In fact, we can simulate this. So I have a web server here on the computer. Normally, this is example 4. If I go into example 4 and click on index.php, which is what I'm seeing now, suppose I am on suppose I'm bad at system administration and I screw up, or I'm on a shared web host and someone else screws up. Let me become root for a moment. So for those unfamiliar, sudo su makes me become root. I don't need a password in this version of the appliance. If I go into etc httpd conf.d, and we'll talk about these things in passing over time. These are conventions in Linux systems as to where things are stored. Notice that there's some PHP stuff in here. Let me accidentally open up mod suphp, and let me do this. Let me turn off PHP, which effectively is what that thing does. And now if I type service httpd restart, this means restart the web server software. And now I go back to my browser and reload. I didn't disable it enough. One sec. php.conf. Oh, it's in there too. That's why. OK. Let's restart the server once more. All right. This happens. Now, granted, you have to be a real idiot to jump through that many hoops to actually expose your code in this way. But most of the time, you're using shared web hosting sites if you're not owning or leasing your own servers. So all it takes is for one simple misconfiguration, or someone makes a typo in the web server or PHP's configuration, the result of which is it just doesn't load properly. And voila, you try visiting a page on the internet, and people see what's inside of your files. Now imagine this file is not something boring like lectures.php, but instead config.php, inside of which is your database usernames and passwords, your Amazon referral passwords, or anything that you're using inside of your website that's private is now public. So in short, we got to get that stuff outside of those directories. So let's see how we can do this. First, let me roll back these changes. Mod suphp. And over time, you'll likely get all the better at administering your own server by playing around with these things. So let's go now into version 5 of this. Now notice the difference. So in version 5, nothing is inside of this root directory. I have a README, which is meant to be documentation after today if you want to play around with these. I have includes and templates still. But now, by convention, I created an HTML directory. I could have called it anything I want. Public HTML is often used when it's your private personal folders. When it's an actual full website, people usually say HTML or docs or htdocs. Doesn't matter. But the appliance assumes HTML. And inside of the HTML directory are only those files that are meant to be web accessible. So what's the implication here? Well, if I look at index.php, notice that the only thing I really have to change is this. I have to require a file that's in .. includes /helpers.php. But this is OK, because the web server is configured to only allow access now to everything below the HTML directory. And even though includes and templates live alongside of it, because they are no longer in the same directory, but alongside of it, you can now enforce at the web server level that nothing outside of HTML will be accessible. And now, in the worst case, if you screw up, you might expose what's in your HTML directory, but you're not going to accidentally expose the templates or the includes directory. And yet your own PHP code can still access it via .. or the like. So admittedly, you do have to tweak your web server configuration. And you, as an end user, cannot do this trick in your public HTML directory as easily if you want to isolate everything to the same folder. Just as an aside, the reason we didn't preach this in something like 50 is because if we want your accounts to be web accessible, you would have to put some files in public HTML, some files in your home directory. Then when you submit things, you get everything else that's in your home directory. So it's just messy. But we'll do it better in this class. So that's an improvement. But let's do one other thing here. So let's now actually start to implement this idea of MVC, the model view controller. We're going to do away with the model today. I'm not going to bother with a database, because we have very small data sets here in terms of lectures. But let's see if I can implement the idea of a controller. So now notice, just as I described in the story earlier, now I only have index.php. So this is the first attempt of mine at implementing the V and the C in MVC. So I'm implementing my own sort of web architecture. Now this gets a little tedious over time. And so in the end, a lot of people do end up using frameworks, as we will for the first project. But let's see what's going on here. So first, I require some helpers. So there's some functions in there, not interesting just yet. But now notice this. Determine which page to render. So I have a little bit of logic at the top of index.php that's asking if a page HTTP parameter is set, go ahead and assign it to the page variable. Otherwise, just assume some hard-coded value, index by default. So in other words, if the user visits a URL of the form, let's say http example.com /?page equals foo, I want to either remember foo in that variable or the default of index. Now, these are ugly URLs, but we can fix that later. So what do I do now? I have a switch that says, well, if the page in question is index, what do I want to render for the user? Well, let me first render the header, which is in the templates directory, and here's a dynamic title like we talked about before. Then render the index. And index, we'll see, is just a template really, but it just has the HTML tags for the home page. No header or footer, just that raw content. And then I'm going to go ahead and render the footer, and that's it. But oh, wait a minute, if the page is instead lecture, let me first check this. Did the user pass in a variable called n also? Because if so, I want to show the lecture template and pass in the variable n. In other words, if the user visited a URL that instead looked like this, lecture and n equals 1, ideally I want that to show me lecture 1's page or lecture 0's page or the lectures page. So we're parameterizing the URLs now. So if I want to do lectures down here, same idea, but I render the lectures template, all the while using that same render function that we wrote a little bit ago. So there's nothing else in HTML. It is perfectly isolated to just the controller. But if I go into includes, I still see helpers.php. And if I go into views, which you can think of for now as synonymous with what we called templates before, now I have index, lecture, and lectures. And just because header and footer are a little special, I put them in a subdirectory. Frankly, I don't really like this approach, but it's what Codeigniter, a framework we'll use, does. So I borrowed their same approach. So notice the structure again is controller is in HTML, views are in views, and includes is just everything else that we might want to embody. So let's see the result. Let me go back to my appliance in Chrome. Let me go ahead and choose version. Let's see, this is version, where was I just now? 6. And by 8, you'll be amazed. Go into HTML, lectures, and it seems to be working. But notice the new URLs. You know, it's not the prettiest of things, but at least we've kind of started separating out our code functionality. As an aside, this is not normal. The fact that you can see HTML and includes and views and click on any one of these directories is a result of our being in a lecture environment and not in a production environment. If this were a production web server, we would cut off access to everything except HTML. All right, so this doesn't feel perfectly clean just yet. You know what's really bothering me? If only because I'm a little anal, those URLs are horrific, right? That's sort of like 2001 style URLs. We can do better than this. So what do URLs usually look like these days? For something like this, I feel like I'd like to see /lectures or /lecture/0 or the like. Now, there's actually some motivation for these, right? So search engines, for instance, typically will index URLs that look like actual file names much more effectively or at all than they do things that are just parameterized, right? You can have an infinite number of parameters, but really this is meant to represent one resource on the internet. So you really want the world and Google and Bing and the like to see URLs like that. So how do we actually support that? Well, because we now have full access to a web server, notice what I can do. In version 7, I pretty much have the exact same structure. If I go into my HTML directory, it looks like I have the same thing. But let me do an ls-a. Turns out I put an additional dot file, a hidden file that is called .htaccess. This is something that the A in LAMP uses. Apache is probably still the most popular web server software in the world. It's fairly high performing. It's perfectly free. And it's pretty much just omnipresent, though there are even faster solutions for certain types of workflows. But notice what I've done here. I've written these fairly arcane commands that, frankly, even I copy and paste or Google almost every time I try to write stuff like this. Rewrite engine on, so that means turn on something called the rewrite engine. Rewrite base just means what is the base URL in question. Unfortunately, this is necessary sometimes. But if you're making a real website that lives in the root directory, you don't even need that. And then the next 2 lines are fairly self-explanatory if you know regular expressions. We have here if the URL that the user has visited at this directory starts with lectures and ends with lectures. So remember the caret symbol is the beginning of the string, $ end of the string. What do I want to do? So if the user visits something /lectures, I want to actually rewrite that request secretly on the web server as going to index.php page equals lectures. So the user is not going to see this. This is not a redirect in the 301 or 302 sense. This is secretly map this request to index.php on the local server. Similarly, if you see lecture /something $, go ahead and a little presumptuously map that to index.php, $page equals lecture, ampersand n equals $1. And the $1 means it means the variable. So it's a capturing. Whenever you use parentheses in regular expressions, it usually means you're capturing the value and storing it in numerically indexed numbers, $1, $2, $3, and so forth. So the end result here, even though the code base is identical, if I go into version 7 here and go up to my HTML directory, notice that not only do I get the beautiful base URL, which was a given, but now, wow, look how neat that is. Right? And it works for lecture 1 and so forth. So anytime, every blog on the internet does this kind of trick these days, where you have these crazy long addresses, but that nonetheless map to some kinds of HTTP parameters on the inside. So this is a homegrown MVC solution. Let's end by looking at one that's sort of real world. So in the real world, there are a lot of frameworks that are meant to simplify or at least expedite the sort of process that we just went through. Because in fact, if we started using my homegrown MVC solution, we would very quickly start to realize, gee, I wish this function existed. Or gee, I wish this function existed. And by functions, I mean things like form validation or error checking or a lot of the tedious stuff that you have to deal with any kind of web development. It'd be nice if someone handed that to me. So folks like Codeigniter or Yi or Cake PHP or Symfony, or there's dozens of PHP and Python and Ruby frameworks out there. But among the simplest in the PHP world is this thing called Codeigniter, which has both pluses and minuses. But what it will allow us to do once downloaded and installed before you start, whoops, wrong lecture, before you start writing code, is it will implement this workflow for us. So Codeigniter comes with a single index.php file, much like we just wrote ourselves. And then all of these arrows and boxes represent various modules or classes that these folks have written that your code then becomes part of. So routing just refers to the feature of Codeigniter, much like my htaccess file, to figure out where certain requests go based on the URL. Security means scrubbing your inputs for you. You never have to call HTML special chars again or remember what the function's called. All that just happens for you. Application controller, you write this. This is your controller that actually implements your particular application. The views you write. But caching, this idea of keeping around all the hard work I just did, let the framework do that for you. And then all of these boxes back here just refer to either one, additional library functions that you get for free, like a render function, or things called models, which represent actual things that you might have in a database. So let's take a look. Where did this come from? If I Google Codeigniter and go to downloads, I literally, to get started with this, downloaded a big zip file from codeigniter.com, and then I unzipped it, and I started deleting things I didn't care about, and I was left with this directory structure. And this will be among the activities in this week's lab and also with the first project. So this is the last MVC example here, but this time I'm standing on the shoulders of this framework called Codeigniter. So let's look in HTML first. In HTML is this index file. And it's a little scarier than mine, certainly, but frankly, it's like 80% comments. And this is essentially doing what my controller was doing. It's looking at the URL and figuring out to whom to route this request. So I should never need to touch this index file after I configure it for the first time. So I made a tiny little change. I changed quote unquote system to /system. Because even Codeigniter, by default, assumes you're going to put everything in the equivalent of public HTML. I don't like that. I want to put the dangerous stuff outside of the HTML folder. So I added a .. there, and I added a .. somewhere else in this file that did the same thing. Yeah, it's elsewhere in the file. All right, so that's one of 3 directories down. Let's see what's in the other 2. So system, I really don't care about. This is Codeigniter. All of the code that that group of volunteers wrote lives in that directory, and it provides you with all of the features that you can then start taking for granted. What do I mean by features? Well, let me go back to Codeigniter's website for just a moment. Go to user guide. And what you'll see here, frankly, this is, I always forget about this. Bad user interface, but if you want to see the table of contents, you have to remember to click up here, and then this comes down. But this is to say there's a whole lot of functionality. And we're not going to care about most of this, but what the laundry list of functionality means here is that if you do want things to manipulate images or form validation or a whole bunch of common tasks, kind of comes for you out of the box with something like this. But let's see the MVC aspect of it. So system is not interesting, so that leaves only application, which, as the name suggests, requests is my application. So in the application folder, and again, the spec in the lab will walk us through this, the config directory has some configuration. When we care about a database, it's going to have my database username and password and stuff like that. In controllers is going to be my application controllers. So we'll see that in just a moment. And then in views are going to be the templates and the actual visuals of HTML that I want to render. So let's go into controllers, and there's just one. All I wanted to do was re-implement the idea of this homepage for the course. And here's the convention that I simply have to follow with Codeigniter. This is a homepage.php file. Notice that I'm defining a class called homepage. I have to capitalize it with a capital H. The file has to be lowercase homepage. These are just stupid but arbitrary conventions that all these frameworks typically make you adhere to, that you can often override them. A little cryptic, but I'm saying extends CI controller. So we talked about the notion of a stock class, which doesn't really have any notion of hierarchy. But if you think, as I think I mentioned last week, about real-world objects like human, and then you have men and women as specific versions of humans, you can imagine some kind of hierarchy in this world of object-oriented programming. And that's what this is alluding to here. There is a class called CI, Codeigniter Controller, which has a bunch of functionality built in for free. And by saying homepage extends CI controller, I inherit all of that class's functionality and functions and features, but I can add my own. And all I'm going to add is the following. If I add an index method, that is the method that will just automatically get called when I visit the default URL in my site. The method lectures will get called automatically, thanks to configuration of Codeigniter, anytime I visit /lectures. And lastly, lecture will get called automatically when I visit /lecture/0 or /1. Moreover, it will be passed whatever is after that last slash. So the nice part here is, frankly, the code just looks a lot cleaner. And you might hate certain aspects of any of these frameworks, but it just makes it easier to get up and going quickly. Because lastly, what I have in my views folder is just the layouts and HTML. So I have a homepage directory, which should be where my index, lecture, and lectures files are, and templates. Templates just have header and footer. So in homepage, I have the same kind of stuff as before, super simple index. If I go into lecture, super simple lecture. And so the end result, after all this, 8 versions later, rather than roll any of this myself, if I go into version 8, HTML, voila, I have the same aesthetic result, but I dare say I wrote much less code. And if I now want to start adding other features, a video page, a labs page, and the like, no more copy-paste. I can genericize all of that, write one method like lecture or lab, and then output dynamically only the code I care about. So this is just the beginning of better designed frameworks that we'll look at more in detail next week. First lab will be tomorrow. More information on the course's website. Spec will be up tomorrow. See you next week.